Now this one is evaluate the 6 trigonometric functions. So these are not on the unit circle. So we have to do something different. We actually have to go back to old school on how to evaluate. So if I want to evaluate the 6 trigonometric functions, and if I'm given cosine of theta is equal to 1/3, what I need to do is like go back to what we originally did, like create a triangle. So that's exactly what I'm going to do here. Say, all right, here's theta. Cosine, remember, is adjacent over hypotenuse. Now I can use the Pythagorean theorem here, right, to go ahead and find this missing side. So remember, 1 squared, plus x squared is equal to 3 squared, right? And when I do that, I'm going to get the square root of 8, which can be simplified here to a 2 square root of 2. So now I have all sides of the triangle. Now again, remember my adjacent side is between my angle and my 90 degree. 3 is always the hypotenuse, which is always directly across from 90-degree angle. And then opposite of your angle, right, is called the opposite side. So now we just need to remember our trigonometric functions here though. And this one sometimes students do forget. So just remember a sine of an angle is going to be the opposite over hypotenuse. Cosine of an angle is equal to the adjacent over hypotenuse. I don't know why I'm writing it like this. Yeah, and then the tangent of theta is equal to opposite over hypotenuse. Now, I don't have room, opposite over adjacent. What am I doing? Jeez, man. Adjacent. Now, I don't have room to do the reciprocal functions, but hopefully you recognize the reciprocal is just going to be those flipped, right? So here's our theta. So in this case, if I want to find the sine of theta, that's going to be opposite over hypotenuse. So that's going to be a 2 square root of 2 over 3. Cosine of theta, we actually already have. That was given to us. That's 1 over 3. And tangent of theta is going to be opposite over adjacent, right? So that's going to be a 2 square root of 2 over a 1, which is just 2 square root of 2. Now, the cool thing is for the reciprocal functions is just flip them, right? So if I want to find the cosecant of theta, what I'm simply going to do is just flip this 3 over a 2 radical 2. Now you can rationalize the denominator. When you do that, you get a 3 radical 2. That'd be radical 2 times radical 2, 2. So that'd be over 4. For the secant of theta, you just do a 3 over 1. And for the cotangent of theta, cotangent theta, I would just have a 1 over 2 square root of 2, which again, you can rationalize the denominator, multiply by square root of 2 on top and the bottom. And that'd be a square root of 2 over 4. Okay. Now, let's go ahead and copy all these again because I don't want to rewrite them. And let's do it from this case. Now, for this next problem, things do get a little bit more tricky because you're like, Mr. McLogan, I don't have a angle that's on the unit circle. All I'm given is a point. How am I supposed to do this with just given a point? Well, remember, this point is not on the unit circle, so don't try to do that. Do not do that. That is the most common mistake that happens here. Do not do that. What you are going to have to do is plot this point. So we have 1, 2, 3, 4, 5, 1, 2. So we have 5, -2. Now what's cool about this is we can create a triangle here. 5, -2, right? And then from there, we can also go ahead and find the hypotenuse, right? So we have a 5 squared plus a -2 squared equals, well, that's going to be what, a 29? So let's call this an x squared, right? So that's going to be a square root of 29 is going to be your hypotenuse. Okay, so square root of 29 is going to be your hypotenuse. Let me actually rewrite that a little bit more, a little bit better. So what you do is basically you plot the point on the plot the point on the quadrant system, and then you now use Pythagorean theorem to find the hypotenuse. So now let's go and evaluate. So sine, remember, is opposite over hypotenuse. So here, another thing I want to mention is your angle is going to be what we call our central angle. So it's always going to be at this point. So make sure you draw your angle. Always make sure you have a side along the x or always make sure you have your side along the x-axis. Okay, always have a side along the x-axis. We're not doing this across the y because we have to use our theta. We have to be able to use our theta, which is going to be a central angle in this way. So always make sure you have a side along the x-axis. Very important. So sine of theta is opposite over hypotenuse. So therefore, that's going to be a -2 over square root of 29, which you can rewrite as a negative 2 square root of 29 over 29. Cosine is going to be adjacent over hypotenuse, so that's going to be 5 over square root of 29, which again, that's going to be a 5 square root of 29 over 29. Tangent is opposite over adjacent, so that's going to be a negative 2/5. So cosecant, the cool thing here is like now I can just do the reciprocal, like just flip them, right? So I can do a square root of 29 over a negative 2. Ah, much better. Secant, I can just do a square root of 29 over a 5. Ah, much better. For cosecant, and then I can do the cotangent, which is just for the cotangent, I can just do a 5 over a negative 2. Ah, much better. All right, let's do one more. Now, on this problem, though, it even gets even a little bit trickier, okay? And the reason why this problem gets a little bit trickier is because now we have a triangle, but in addition to having a triangle, we have a constraint. Oh, what's up with these constraints? Okay, so we have tangent of theta equals 1 pi over 3, but it says secant is less than 0. So we got to understand, when is secant less than 0? Remember, secant represents like the 1 over x, right? And you could think about that as like, let's think about the coordinate point, 1 over x. Well, when is x negative? X is negative in the second and the third quadrant. Now, when is tangent positive? Tangent is positive, okay, in the first and the tangent is positive, which 1 over 3 is positive. Tangent is positive in the first and the third quadrant. So secant is negative in the second and the third. Second and third. Tangent, let's maybe draw this up. Come on. All right. So secant is negative in the second and the third quadrant, right? Whenever x, secant's 1 over x. So whenever x is negative, that's second, third quadrant, it's negative. Tangent, though, is positive in the first and the third quadrant. So what is the only triangle here that works? It's going to be one in the third quadrant, right? So then what I'm going to do here is I'm going to draw my triangle. Let's draw it maybe bigger. In the third quadrant. Now it said tangent of theta, which is 1 over 3. Now notice again how my triangle here has that x-axis, right? My 90 degrees right there. So there's going to be my theta. And it's what? Opposite over hypotenuse. So that's 1 over 3. Add those together. Was it 1 over 3? Yeah. No, I don't want to do 1 over 3. I don't want to do that. Let's do 4 over 3. There you go. 4 over 3. The reason why I want to do 4 over 3, because now I recognize this is a Pythagorean triple. Let's make our life a little bit easier here. I already did radicals. And that's going to be a 5. All right, so sine is going to be opposite over hypotenuse, 4/5. Cosine is adjacent over hypotenuse, 3/5. Tangent, opposite over adjacent, which we already had, which is 4/3. Cosecant is just a reciprocal of sine, so that's 5/4. Secant, reciprocal of cosine, 5/3. And cotangent, which is reciprocal of tangent, is going to be a 3/4. Voila.